All right. So, today we have some things to do. Not too much. Okay. So, I just gotta continue working on my QAQC stuff. And from there, I'll work on a little project for Feki. Let me put it, actually, come to think of it. Let me just mess with that 1 second. Let's try something. So some music in the background. Make sure it's not too loud. But yeah. Anyway. Okay, so fuck me. Oh, I lost it. Whatever. Okay. Yeah, just gonna mess around with a few more things. Eat paint, yes. Just gonna mess around. I gotta get some things ready. So, how was your day? It was alright. Long, as usual. But it was alright. One thing at a time. Alright. Let's see how this looks. Oh, that image needs to be rotated. All of them need to be rotated. Let me mess around with that. Alright, let's try this. It's still rotated. That's really awkward. Trying to get these pictures to look half decent. Oh my god. Anyway. It's still sideways. Why is that? Alright, give me 1 second. I'll be right back. See, that's what I was trying to do, but it doesn't seem to work. So whatever. Anyway, let's get to it. Yeah, I guess I'm gonna have to mess around with the picture, but I'll do that another time. So. Okay. Okay. So just fix a few things before I upload it back to Alex. Directing inspection activities. Surveillance of procurement documents, approval of suppliers, blah blah blah, retrieving, maintaining quality records, calibration of measuring and test equipment, approval of disposition of conforming articles, corrective action coordination. Okay, 6. Instructions and drawings. Work instructions. 1. Gather materials. 2. Connect negative lead of the battery. Negative lead of the buzzer. And one end of the potentiometer. Connect battery. One end of the potentiometer. One lead of and pin 4 of the op amp to a common ground rail. This is the image that talks about that. Then it says connect the positive lead of the battery, one lead of 10K thermistor, the available end of the potentiometer, and a pin 8 of the op amp to a common supply rail. Connect the center tap of the potentiometer to pin 2 of the op amp. Connect the available leads from the 4.7K resistor and 10K thermistor to pin 3 of the op amp. So let's go from the beginning. Connect negative lead of the battery, of the buzzer, one end of potentiometer, one lead of the 4K resistor, and 4th pin of the op amp. So negative, negative, one lead, one pin to the negative. Okay, seems about right. Connect the positive lead of the battery, the buzzer, no. One lead of the 10K thermistor here. The available end of the potentiometer and pin 8 of the op amp to the common supply rail. So the first pin, does you say one end, the other end? Okay. Connect the center tap potentiometer to pin 2 of the op amp. Pin 2. Connect available leads 4 resistor and 10K resistor to pin 3 of the op amp. Connect pin 1 of the op amp to the positive lead of the buzzer. Work or desk instructions are utilized in support of the quality manual to improve the control of the specific operation or evaluation, but in no circumstances shall these documents supersede or change requirements of this manual. Drawings, specifications, and or catalog criteria shall be used to control the technical requirements of products offered to our customers. This is the schematic of the drawing, and this is on breadboard using a program. Next, 9. Identification and control of items. The original equipment manufacturer articles will retain their identity through our receipt, stocking, and delivery function traceable to the procurement and receipt documents containing acceptance status. Breadboard 10K, no. Blah 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 blah. Supply materials or products. Inspection 11. Control the measuring test equipment. Is the alarm triggered when it's exposed to heat? Is the battery charged? Or does solder bridge is clean and no blemishes pass? Okay, seems good to me. So I will save. Let's check this out. Does it have all our names? Yep, it does. Okay. That's sent to him. If he doesn't say anything in a certain amount of time, then whatever. Anything from school. Assignments. Just that. Okay. So now that's done. Let's see what else we have to do. Kerchoo. Print, talk, paper, ethics, other readings, integrated notes. Then wireless lab I don't have to do. So integrated notes. Wireless lab. Let's see. These are all the readings. Then I need to print. Immanuel Kant. I need the ones from Immanuel Kant. They're not paged. What the fuck? Anyway, I need to print all of this anyway, so. Not the entire page, though. So let's put it at 75. Alright. I'll be right back. Okay. Let's print that. Huh. Okay. Back to my circuit I wanted to deal with. Let's just okay. So here the idea for this circuit will be to, if I have to draw it, which I will do. The idea is to take a box with 16 switches, and from there converts it to four wires, which is then connected to a decoder, which will again bring it back to 16, so 0 to 15. So this is basically what I want to do. This will be for industrial machine. So what we'll do is we'll start with the smaller one, which will be 7 switches, so 0 to 7, which from these 7 switches will output different states. In this case, of the 7 switches, we want to consider that if I have all my switches and I say, okay, I want to switch all of them on, well, I want all of these to be translated to only one output. So, doing this with this. So basically, as you can see here, what I will do is I'm taking 4 switches, and trying it there. So, but now I need to take another set of switches. I will replace. It needs to be. There are 7 switches in total. 0 will be nothing, basically. So dip switch with 3. Here, they're all connected to 5. Hello, Evan. Oh. All right. So this will be is a project for Feggy. That my coworkers have been trying to do, or whatever, for a very long time, and asked me if I could do it. So I will do some of this, some of this, some of this. Basically, the idea is I have a switch box, and within the switch box there will be 8 switches. Each switch or combination of switches will output a specific state. So basically this is a decoder, 8 to 16 decoder. Can I just save myself? Uh, 8 to 16 decoder. 4 to 16 decoder. Well, 4 to 16 decoder is a thing. Obviously. But what I'm trying to do is an 8 to 16 decoder. So this one's a little different in a sense where let's make this blue to differentiate. Nice. It's a slightly different shade of blue, but who gives a fuck? Alright. So, what I want to do is I want to take these inputs and then convert them into different states, which then, from there, I will then put this through an encoder. So first, I need to find a way to, again, differentiate between each state. So I need to replace with 8 isolated. Okay. So in this case, we can consider there being A, B, C, D, E, F, G, H. So we can consider all of these different states, basically your inputs and what's going to change. The thing is, between all of them, there's something in common. So if we look at, for example, a truth table, we have to find a way to So 1, 2, 3, 4, 5, 6, 7, the G. Two to the power of 7 is 128. We could use the 0 state to our advantage. In fact, we can use state 0 to our advantage. We don't need to make it that big. In fact, what we can do is, because in the configuration I have, state 0 will never exist, therefore state 0 can also be important for the second set of switches to work. Now, in this particular case, we can say we can build it because we have our logic for the first 4 switches, which will do its thing, and then for the last 3, which incorporates the not everything. So we can begin by creating the different states. So if we look at A, B, C, D plus A, B, C, D naught plus A, B, C naught D, blah, blah, blah. Or on the truth table, (32 by 8). We can see that these three are the same regardless of where you're at, as long as you respect A and B. So 0, 1, 1, 0, 1, 1 will always be the same for everything if dependent. That's when it's while it's completely dependent on A and B. So we can work with that by saying, okay, so we have our 3 AND gates responsible for those states. So like we said, we have A1. So we have to remember that all 4 0, or rather the first 2 0, which we will never use, except, sorry, all 4 0, the first 4 0, basically zeros after that are used. So let's see, because I might have made a mistake due to this particular, but we'll see. Also this particular case, but how would it, how did I deal with it as 3 variables? Did I not consider 4, or did I consider 4 by itself? Let's just assume. So we are going to, we see we have set it up so that the first switch is connected to the first. So this will be our LSB, this our MSB, and this as well. LSB, LSB. So connect D and C to both low, D to high, C to low, C to high, D to low, and C and D to high. So this is our 4. This is our 4 possible states for the first 2 bits. The second bits are dependent on what these are. So we have to then take this and say, okay, that's all cool and all, but I must also know if these also exist. So B and A, B naught, A naught, B, A naught, B naught, A, and B, A. So this is our different states. From there, we say, okay, So we want state 1 to exist if and only if this and this are true. Step 2, 3, take all of this. State 4, state 5, state 1, state 2, state 3, state 4. It's dependent on both low, both high, so I have to do it 4 times. These states are completely dependent. They depend on these 4. So the first 4. So 1, 2, 3, 4 indicate the first this in combination with that, so it's 1, 2, 3, 4, 5, 6, 7. So I have to make this many combinations for each one. So I make 16 different combinations. For the first state. Okay. Trying to think if there's a way to reduce this, because I probably is. But I cannot think of it at the moment. So if I need to show off these 4 possible states, C and D, doing so, I need to differentiate between the different states here, so I need to have a state for each of these. So, feeling this is definitely one way of doing it, but This is basically a decoder, 224 decoder. Let's go find. Is that a thing? Can we search? Two to four decoder. Okay. Wait, we need specific 224 decoder. We want to decode the states, so but which IC is it? 4 to 16. Because I don't want any control pins on mine. That's the only difference. In fact, what I'm trying to do is this. Right? 4 to 16 decoder. This uses a lot of 4 input AND gates. Let's assume I didn't have 4 input AND gates. I'd have to use... I guess I could use 4 input AND gates. And CMOS, 5 volts. 4 input AND. Let's remove labels so we can, so it's clear. That not state will not be used. We will use what we've said before, which was two by 8. So not. So D, not. C, not. Not. Both of them, not. Just B, not. Both B and D, not. B and C, not. Let's bring this all the way down. Any more room? Put more gates. Then we need this one, this one, and that. Then there, that one, and not. I want this and D, the rest not. I want A and C, the rest not. I want A and C and D, but B not. I want A and B, but the rest not. I want A and B and D, that not, but C not. I want A, I want B, and I also want C, but D must be not. A and B and C and D. Oh my god, what have I done? Alright. So this is all the possible states that exist. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. 15 because the first one, be it all 0, will be messed around with these 3 inputs. So I actually could do that and add the last one right here. I'll make this purple. That color is not obvious. Well, light blue. That one's a little better. Take these three, move it here. What do we see? We decided that as MSB, second, and LSB. And finally here. All right, so when all of them are low, this in conjunction with these three, so I need to make another one of those. So I need to make a circuit that deals with 3 bits as opposed to 4. Now, so I have all those states. Now I have to differentiate between those 3 in conjunction with this. You know, things that I could try. Let's see what I get from here. Can we replace this with a bigger one? 8 isolated. Indeed, we can with 9. Let's get another one of these. Bring it down. Let's break it down. I'm going to play some music in the background for everyone. Give me 1 second. Right. There. All right. Alright. So we're going to replace these bus resistors. No, it's isolated, sorry. With 220 ohm resistors. Put another segments display. connect the right one to the right. Alright. Those aren't used. Okay. Some error occurred. What is the error? Apparently something is wrong. Okay. Let's look at each individual one. So, LSP. State 1. That's fine. That's fine. That's fine. It's fine. Yeah. Yeah. Yep. 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 What is happening here? No. It's 2 plus that one, yeah. Is it in the right orientation? One connected there, one connected here. The other 2 connected, and one there and one there. There. Yes. 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 All right. should technically be okay. No. Where is the problem now? No warnings. It's not telling me. Oh, it's the switches. I know. Figured it out. It was the switches the entire time, but I also had messed up some of my connections, so. There you go. Okay. 1, 2, 3, 4, 5, 6, 7. Third to the last. Nice. 9, 10, 11, 12, 13, 14, 15. Very good. So the 15, the decoder works as it should. And now for these pins. These 3 other pins that we will be using. I could replace this with the one that's smaller. Okay. Now for 3, it's the same idea. It's just that there is it changes based off this input. Including, with this included. So let's go. We have that already, so we just need this. We need to agreed LSB. We can use 3 input as opposed to in CMOS. There you go. In the case of here, there is 2. Or no, there's 4. There is. All 0. Well, we will not use that one, so we'll only use so we will not be using 0. Well, actually, yes, we will be using 0, 0. We will not be using the first one, because if we use the first one in conjunction with this, it implies that there is a state when all four are low, so we will not do that. Instead, we're going to skip to the first one. And because we're only dealing with 3 more states, we want to do it like this. We want so inverter is a light blue, so A why can't I? There. Give myself a little bit more distance. All right. One sec, BRB. All right, I'm back. Okay. That's so weird. What the fuck? Okay, I guess I'll just deal with it. We can just connect it here because we know that it goes around. We'll then do some of this. Oh. We'll use the gap in between to help us guide through. Can't move because there's wires overlapping. Shit, what happened? Okay. All right. All right. So this will be our decoded thing for here. Now we just need to make it do we even need this? Yes, we do. Because if, for example, we were to flip this high and this high, then we'll have two lights showing. We don't want two lights showing. So My method is flawed. Because there's a problem where once all of these are flipped, it doesn't know to move on to the next. So seems to me I just have to it's my enable pin. Right. No, I can't. It's this one. It is this one. It's just that I was trying to put it together with another one, but I don't seem that I need to. In fact, I don't even need to go through that because I could just do this. I could place one of these with one of these and basically just switch between enabling this or enabling that. So for this to work, I'd need enable as well. I need 2 enables, but I'd have to redo the wiring again, so let's just not deal with that. Let's just open Multisim again. And find those ICs. So let's do 3 to 8. What is G? Those have to be set low. G1 if it's high. Yeah. One. No. 238. One 37. 74, 137. Well, yeah, that's what it is. So take one of these. Do a 74. 154. This is a 4 to 16. It's different from the way it's set up. Because this... latch enable, data enable, active high. So this is an active high input. This is 2 active lows. So maybe there is one with without that. $45.14. Well, I guess I will just compensate for it. So. Could say if all are high, between 4 variables, is there a difference? Let's see. So there you go. Is there a way I can make this active high? I mean, it doesn't really matter, but When is it that we need to switch it? If my value exceeds 15. Or if my value exceeds switching more than 4 switches. So each one is essentially a different state. Would I need 2? And this hooked up like this. But when would I know the switch? Because just through the 15 states, I want the 16th state to only come on in 2 possible cases. When pin switch 5 because we have (16) states here. Well, with 8, add another 7. It's escaping me right now. I can't think of it. Eight switches. Eight switches is equivalent to 256 states. Obviously, I don't want that. So what I want to do is it to switch the second one if and only if the first one equals 15, but I want to also flip here, and it tells me. Those in conjunction with the 4 inputs. 16 different states. Of the 16, each of those times 3 times 7. I can't figure this out right now. Faggy design 2 for now. Alright, well. Anyway, I'm just gonna get off. Just wanted to do a little bit of homework, print some stuff out, and try some things. That's all. With a different circuit, but I'll deal with it another time. Alright, I'll see you later, Evan, and till next time.